Students, today we are going to be solving additional maths, and we are going to take the pure maths section of that, and we are going to do the year 2018. First question, they say given that x plus 2 is a factor of f of x, where f of x is equals to x cubed minus x squared plus kx plus 4. A, find the value of k. To find the value of k, you just need to equate the factor to 0. That will give you x equals to negative 2, and you replace negative 2 in the function. That's to have negative 2 cubed minus 2 squared plus k into negative 2 plus 4. So if I do that, I'm going to have negative 8 minus 4 plus 4. So I'm going to, therefore, okay, excuse me, I have this, negative 2k equals to 0. So from there I'm going to have 2k is equals to negative, I'm going to have negative 8. And therefore k is going to be negative 4. So that's the value of k. And let's say the B part of the question says the value of k factorize f completely. So the value of k means the function f of x will now become x cubed minus x squared minus 4x plus 4. And since we have a factor from above which is x plus 2, we can carry out Euclidean division. Okay, so a factor is going to be x squared. Here I have x squared, and I'm going to have plus 2x. Here I subtract. When I subtract, I'm going to have negative 3x squared minus 4x. So I'm going to add again plus 3x. So I'm going to have here, okay, minus 3x rather. I'm going to have here minus 3x squared minus 6x. And when I subtract again, I'm going to have 2x plus 4. So later on, the next factor that's going to go is going to be 2. Okay. So now to factorize this completely means f of x can be written in the form x plus 2 into x squared plus 3x plus 2. And we factorize that, we're going to end up with x plus 2 into x plus 2 plus x plus 1. So factorizing f completely is equals to this. Okay. Now we move on to the C question, the second part of the question, Roman 2. We're going to have, you see, given the roots of the equation, 2x squared minus 3x plus 5 equals to 0 are alpha and beta. Then we're being asked to find for the value of alpha plus beta and alpha beta. So alpha plus beta, sum of roots which are abbreviated SOR, is going to be alpha plus beta, which is negative b on a. Here b is represented by negative 3, and a is 2, and c is represented by 5. So we're going to have here negative 3 on 2, giving us 3 on 2. And we're going to have the product of root POR. We're going to have alpha beta equals to c on a, which is just 5 on 2. So that's the value of alpha and beta. Now, we're being asked to evaluate. That's the A part of the question. Now, we're saying we are being asked to do for the value of alpha squared plus beta squared. Alpha squared plus beta squared is actually equal to alpha beta squared minus 2 alpha beta. From above, we got alpha plus beta and alpha beta. So we're going to have alpha squared plus beta squared is equivalent to alpha plus beta all squared, that is 3 on 2 all squared, minus 5 minus 2 into 5 on 2. Exactly. So we're going to have this, we're going to have 9 on 4 minus 5. And when we do that, we're going to have negative 11 on 4 as alpha plus beta. So now we move to question 2. So question 2, they say committee of 2 boys and 1 girl is to be selected from a class of 4 boys and 3 girls. Find the number of ways in which this committee can be formed. A, to find the number of ways in which this community can be formed. Say n should be the number of ways, and to choose 2 boys and 1 girl from a class of 4 boys and 3 girls, you just need to say you're going to have 4 combination 2 for the number of boys times 3 combination 1 for the number of girls, and 4 combination 2 with your calculators you can get. We are going to have 4 combination 2 is given by 4 factorial. Remember that when you write NB, we know P combination cure is equal to P factorial on P minus cure factorial times cure factorial. Same here, we're going to have 4 factorial, 4 combination 2 equals to 4 factorial all over 2 factorial times 2 factorial. So it's going to give us 4 times 3 on 2. Give us 6. And they have 3 combination 1. 3 combination 1 is equal to 3 factorial on 2 factorial times 1 factorial. 1 factorial is just 1. So we're going to have here, we're going to give us 3. So it means the number of ways n will therefore be 6 times 3, which is going to be 18. That's the number of ways, 18 ways. Okay, now the second question, the second part of the question. Okay, let's wipe this way since we're done. Second part of this question is, let's say, write down the first 3 terms of the binomial expansion of 2 minus x to the power 7. First of all, remember that you need to first of all put, must first of all put in a form a plus ax to the power n before we can expand. Yeah, it is not in the form a plus ax to the power n, so we need to first of all arrange it in that form. For that reason, I'm going to say 2 minus x to the power 7 is equivalent to 2 into 1 minus x on 2, all this to the power 7, which gives us 2 to the power 7 times 1 minus x on 2 to the power 7. So I'm going to expand this and later I'll multiply by 2 to the power 7. I'm going to have 1 minus x on 2 to the power 7, which is going to be, if you remember, we have 1 plus ax to the power n is equals to 1 plus n ax plus n into n minus 1 on 2 factorial a squared x squared. So we're going to do same here. And if we do that, we're going to have 1 minus x on 2 to the power 7 is going to be same as 1 plus 7 into negative x on 2 plus 7 into 6 times this on 2 factorial, which is 2, and then I'm going to have negative x on 2 all squared. So I'm going to have here 1 minus 7x on 2, and then have here plus 21 negative x squared on 4. So I'm going to have here 1 minus 7x on 2 minus 21 x squared on 4. So now, remember we have to factorize 2 to the power 7. So now we just need to multiply 1 minus x on 2 to the power 7 by 2 to the power 7. Means the expansion this becomes as such. Going to be, remember 2 to the power 7 is 128. So it'll be 128 into 1 minus 7x on 2 minus 21 x squared on 4. So we see we're going to have 121, and we're going to have 7 times 64. 8. I'm going to have 40. 42, 44. So I'm going to have minus 44x, and then I have 128 on 4 is going to give me 32 times 21. I have 2, I'm going to have 3, and then I'm going to have 4, 6, 2, I have this 7, 62. So I have minus 762 x squared. So this is what we have. So our expansion gives us 128 minus 4 448x minus 672x squared. Okay, question 3. Question 3. In the question 3, they say given that 2 plus t, 4t minus 2, and 4t plus 1 are the first three terms of an arithmetic progression. We are being asked to find the value of t. First of all, since they are given in our arithmetic progression, we know in our arithmetic progression we have t2, that's the second term minus the first term, is equivalent to the third term minus the second term, and so on and so forth. So it therefore means we are going to have 4t minus 2t plus 1 equals to 4t minus 4t plus 2, like we said above. So I'm going to have 4t minus 2t minus 2 minus 1. It's going to give us 4t this way plus 1 minus 4t minus plus 2 rather. So you see 4t is going to cancel with 4t this way. And then we're going to have here 2t minus 3 is equivalent to 3. So we're going to have here 2t is equals to 6. So this implies that t is equals to 3. So the value of t is 3. Now we're being asked to find the sum of the first 10 terms. So first of all, the value of t equals to 3 means the first term t1 becomes the first term t1 becomes 7. The second term t2 becomes 10, and then the third term t3 becomes 13. So from here we are less than 1. Now the system of the progression. The system of progression, that is t6. T6 generally we have this word we are looking for. Generally we have tn for a geometric progression is equals to a to rn minus 1. So we're going to have t6 will be equivalent to a is 2, and a half r is equals to a half, and a half 6 minus 1, which is 5. So our comes on the left side of the board. Okay, so I have here t6 therefore is going to be 2 into a half to the power 5. And know a half to the power 5 is 1 on 32, so give us 2 on 1 on 32. It's going to give us 1 on 16. So the sixth term is 1 on 16.